Hi students, I welcome you all for the sessions. In last class we discussed about chapter 4, that is we started chapter 4, that is quadratic equation and complex numbers, and we discussed about some how to represent a complex number, the given expression in a complex number, and we discussed some properties of the complex numbers, that is addition and subtractions, division and multiplications, how we have to express in the complex numbers, and also we discussed about modulus and inverse of the complex numbers, right? Based on those concepts we will be having exercise problem, that is a 4.1. So we'll be going to discuss solve the exercise problem 4.1 in this part 2 video, right? So now first one, so here up to 10, 1 to 10, we need to the given expression we need to express in the form of a complex number, that is a plus ib, right? The first one I am taking here 5i into minus 3 by 5i, right? This is a simple expressions given. We need to express in the form of a complex number. Here I into I is I square, 5 into 13 is what, 5 into 3 is minus 15, 15 I square divided by 5 is there. Okay, then here 5 ones are 5 threes are, so it is minus 3 I square, so divided by 1 is there. Okay, and see here minus 3 I square is value is 1 minus 1, so minus 3 into 1 is 3, it is 3, value is 3, therefore we'll be expressing in the form of a plus ib, that is 3 plus I 0, 3 plus I 0 we can write. Now second example we'll take I to the power of 9 and I to the power of 19. So I to the power of 9 I am writing I cube to the cube. So 3 3 is 3 3 is 9. Okay, and here I to the power of 4 to the 4 I am writing. 4 4 is 16. 16 into I cube is what? So it is 19. I to the power of 19. So I cube we can write as a I square into I. So I square value is minus 1. Minus 1 into I is it is minus I. Right, we can write I cube value is minus I, right? Minus I into whole cube is there, and plus I to the power of 4 value is what? I to the power of 4 I square to the power of square we can write I square value is minus 1, minus 1 of a square is what? Plus 1. So therefore plus 1 we can write 1 to the power of 4 is 1 only. So I to the power of 4, I to the power of cube value we already we know that is minus I, it is minus I. So now this one we express. So I minus I to the power of cube is what? Here minus I to the power of cube only. So then I cube value is it is minus I. It is minus I. Therefore we can write this one 1 into minus I is it is minus I. Right? It is minus I. So minus I to the power of cube is minus I is here. So minus I. Therefore minus into minus is plus I, plus I minus I, so I minus I is 0. So the second one is 0, so we can write 0 plus I 0 we can write, right? Now third one, if we come across third one, so third one is given I to the power of minus 39. The third one expression is given I to the power of minus 39. This we can write as a 1 divided by I to the power of 39, right? I to the power of 39, and when we are writing this one I to the power of, so I to the power of we can write square of 18 is 36, 19 is 38, 19 we can write 19 into 9. So I square value is what? Minus 1. Minus 1 to the power of 19, it is odd number, it is odd number, and into I. So 1 divided by odd number is means here minus is there, 1 into I, therefore it will be having minus 1 into I. Then when we are when this like this problem will come, when we need to multiply here. So when like this problem will come, a solution will come, we need to multiply both side I into I into I, then it will be I. So here minus 1 into 1 into I square will be there. I square is what? Minus 1, minus 1 into minus 1. So solution is I here. So 0 plus I is the solution for this question. Now fourth one, if we come across fourth one, so fourth one is given. So it is a addition is given 7 plus 3 into 7 plus I 7 plus I into 7 plus I is 7. Okay, so means what here? Two complex number is given, right? Two complex number we need to express in the form of a plus ib, right? So I just multiply this one. 3 into 7 is 21, 21, and 3 into 7 is 21, 21i. This is 21i, and this is 7i, and this is I square, uh, I square into 7, right? This is 21. I square is minus 1, then it is minus 7, and 21 plus 28, it is 28i, right? So 21 minus 7 is what? 3 4 16. It is 16 plus 16 plus 28i is the solution for this. Otherwise we can write uh, 16 plus 16 plus I 28 we can write. Now come to the fifth one. So fifth one is given. So fifth one is given as subtraction. So subtractions, fifth one is given subtractions 1 minus I minus 1 plus I power of 6. When this type of subtraction is given, we need to take minus inside. Then it is 1 minus I, minus taking I am inside, then it is plus. So minus is so minus will become as plus, and plus will come as minus, right? So this one 1 plus 1 is 2, and this minus 1 minus 6 is minus 7. It is I7. Okay, so and next sixth one is also similar type of example. So here 1 plus 5 plus I to the power of 2 by 5 minus 4 plus I 5 by 2 is given. Subtraction is given, we need to take inside the here minus. So 1 by 5 I 2 by 5, and this minus I'm taking inside, then it is minus 4 minus I 5 by 2 is here, right? So here 1 by 4, 1 by 5 minus 4. Okay, real part I'm writing one side, and imaginary part I'm writing one side. 2 by 5, 2 by 5 minus 5 by 2. Okay, and then further you simplify this one. So LCM is 5 only here. So 1 minus 20. So 4 5 I is 20 here, and I. So LCM is 10 here. 5 2s is 2 5s are 10. 2 2 4s are 5 5 25. So we can write as it is minus 19 by 5, and here is I minus 21 divided by 10. Okay, this is in the form of a plus ib. Okay, now come to the seventh one. If we solve seventh one, so seventh one is also subtraction is given. Okay, seventh one is addition and subtraction both are given. 1 by 3 I 7 by 3, and 4 4 plus I 1 by 3. First we need to add these terms, and then finally we need to subtract that expressions. Minus 4 by 3 plus I. Okay, plus I. Plus I. First one I will just do addition. So here 1 by 3 plus 4, 1 by 3 plus 4, real part, and imaginary part I am writing here. So it is 1 by 3, right? I into 1 by 3. Then it is 7 by 3 plus 1 by 3. Okay, and then next I'm writing this minus of minus 4 by 3 plus I is given. I will simplify this one, first one. So it is 3 is LCM, and 4 3 is 12, 12 is 13, 13 by 3. This is 13 by 3, and this one is a 8 by 3. I 8 by 3. Okay, now this minus I'm taking inside when we are subtracting the part. So minus we need to take inside, then it is plus 4 by 3, then it is minus I. So now if we write real part and imaginary part separately, these are the real part, 13 by 3 and 4 by 3 real part I'm writing separately. And so I 8 minus 8 by 3 minus 1, right? So now these LCMs are same here. So I'm writing 13 plus 4 is 17, 17 by 3 plus I. So and this is LCM is 3 here. 8 minus 3 is 5. It is 5 by 3. This is the final expression for this given solution, right? So the eighth one is given. The eighth one is 1 minus I to the power of eighth one is we need to solve 1 minus I to the power of 4. So this one we can write I just writing this one 1 minus I square and 1 minus I square I am writing. So it is in the form of a minus b whole square. Okay, and therefore I'm writing simply writing a minus b whole square is a square plus b square minus 2ab. Okay, and then again I'm writing this 1 minus I square is in the form of a square plus b square minus 2ab, right? So then 1 plus I square is minus 1 minus 2i, and 1 plus here I square value is minus 1. So therefore we can write here directly minus 1. So minus 1 and minus 2i. So here 1 1 will be get cancelled, 1 1 will be get cancelled. It is minus 2i into minus 2i. So minus into minus is plus. So 4 I square. So I square value is minus 1. 4 into minus 1, it is minus 4. Solution for this minus 4 plus I0 we can write. Okay, the next one is given. It is in the cube, right? So ninth one is given in the cube. Just we need to apply the formula 1 by 3 of 3i whole cube is given. So this is in the formula of a plus b whole cube. So a plus b whole cube formula, we know that a cube plus b cube plus 3ab into bracket a plus b. So if further if we simplify this one, a cube plus b cube plus 3 a square b plus 3ab square, right? So this we need to write in this formula. So here a value is 1 by 3, 1 by 3 cube, 1 by 3 cube, and b is value is b value is 3, b value is 3i, 3i. So 3i cube, 3i cube plus 3 a value is 1 by 3, 1 by 3 of the square, b value is 3 into I, and 3 into a value is 1 by 3 and b value is 3i square is there. If further if we simplify, it is 1 by 27, and here 27 I cube, and it is the 3 into 1 by 9, 3 ones are 3 3 threes are, right, into 3 I is here. So this 3 will be get cancelled, we will be having only I only, and 3 will be get cancelled here. It is 9i square. And further if we simplify this one, 1 by 27, and it will be and I cube is what? I cube we can write as I square into I square is minus 1, minus 1 into I is it is minus I. So we can write simply is minus I, then it is 27 minus 27 I, and plus here I will be only I remains, and here I square is minus, this is minus 9, and we can write this one, this part real part 1 by 27 minus 9 I am writing, and imaginary part is here 27 I is 26 I, 26 I is I am writing this one I minus 26. Okay, if you simplify this one again 27, so otherwise you write 27, so you otherwise you keep this one 1 by 27 minus 9 I minus 26. This is in the form of a plus iv. right? Now, uh, in the same way, we need to apply here 10th one. So 10th one is you just apply the formula for the uh, apply a minus b whole cube formula. You just apply as we solved ninth one. So a minus b whole cube formula is a cube minus b cube minus 3ab into a minus b, right? Further, if we solve this one, a cube minus b cube, this is minus 3a square b, and this is minus into minus 3 plus, it is plus 3ab square. Okay, you just solve this one. I'm just like next problem we'll be going to solve, that is z inverse. We need to find the inverse of the numbers. So the first one is given, 11th one is given 4 minus 3i. I just take this one is as z. Z is equal to 4 minus 3i. So what is the z inverse we need to find? Z inverse is what? It is a conjugate number to the modulus of square. Right. This is the formula for that. So we need to find z bar. Z bar is what? It is minus, it means it is plus will come 4 plus 3i, and modulus of z is what? Modulus of z is, so square root of 4 plus minus 3 whole square, right? 4 square minus plus 3 whole square. 25. This is 25. Square root of 25. Square root of 25. Z bar is square root of 25, and Z square is 5. Z square is 25 here. Bracket. Z square is here 25. Then when we are writing here, Z bar is 4 plus 3i, and this is 25. We can write this is 4 by 25, I 3 by 25 we can write. Okay, next 12th one is given. 12th one is, so 12th one is, so z is value is given root 5 plus 3i. So we need to find z inverse. So z inverse is formula is z bar to the z square of modulus. So here the z bar is what? Root 5 minus, plus is given, then it is minus, and modulus of z is what? Modulus of z is the square root of root 5 square plus 3 square will be there, right? Then it is square root will be getting cancelled. We'll be having 5 plus 9, then it will be 5 plus 9 is 14, root 14, and modulus of z is root 14, and modulus of square is what? It is 14. Then if you put these values here, z inverse is what? Z bar is root 5 minus 3i, then it is 14. We can write this one is separately, root 5 divided by 14 and minus I, this one I am plus I, and minus 3 divided by 14. Okay, we need to express in the form of a plus ib, right? Therefore I'm minus, I'm taking this side. Okay, next one is I. 13 one is very interesting, minus I. So here z is minus I. So z is minus I means what? Z bar is what? It is minus 1 of square. Then it is it is root of minus 1 square is 1 only. It is root 1. Root 1. Therefore z square is 1 only, and z bar is what? Z bar is plus I. Therefore if we write z inverse is here, z bar to the modulus of z square. So z bar is I is here, z square is 1 here. The solution is I only. Okay. And 14th one is very interesting. 14th one is given. So 3 plus I root 5, and 3 minus I root 5, and root 3 plus root 2i into minus is given here, root 3 minus I root 2. Okay, so this one we need to multiply this here. So 3 3s are 9, 3 here 3i root 5, and this one 3i root 5, and here plus into minus is minus I square of root 5 square, root 5 whole square. Okay, this is in the form of a plus b, uh, Okay, here minus is given. So okay, it is minus is given, then root 3 plus root 2i. Okay, this minus I am taking inside, then it is plus minus root 3 plus I root 2. Okay, then when we are solving this term, these two terms will be get cancelled. So when we are having 9 minus, so square root will be get, it is 5. So it will be plus 5, right? It will become a plus 5, and then we are, so these two terms will be get cancelled, and root 2 I, then we'll be having 2, uh, okay, we'll be having root 2 into root, the plus is there, right? Then we are having 2, we'll be having 2 root 2 I, 2 root 2 I, we are having 2 root 2 I. So if we are solving this one, again we need to multiply I into I. So it is 13, 9 plus 14 I. So then 2 root 2, 2 root 2 I square. I square is minus 1 value. So we'll be having minus 4, 14i, 14i divided by 2 root 2 minus 2 root 2. This is the solution for this equations. Okay. So after the solving the exercise 4.1, so as a small portion is remained in the chapter 4, that is argand plane and polar representations. What is the meaning of this? So we are generally we are writing a complex numbers 2 plus 3i, uh, minus 1 plus 4i. These are the complex numbers. These will be representing in the form of coordinates. I am writing here, this is the x value and y value. So x is the real value and y is the imaginary value. So just I am writing x comma y. So this is x is 2 here, and y is 3 is here. Okay, and here is minus 1 comma 4. So these are the these I am presenting in the coordinates. Okay, so when we are presenting this in a coordinates, so generally we know about this is x-axis and this is a negative x-axis, and just giving x dash, and this is positive y-axis, and negative axis and y dash I'm giving. Okay, so this is the original point, origins, which is having coordinates 0 comma 0, and suppose here this point 2 comma 3, I'm 2 comma 3, x is 2, right? X is 2 and y is 3. Somewhere the point is comes here, a is equal to 2 comma 3. So like this we can represent, and here x is minus 1, x is minus 1 means here comes, and y is 4, somewhere here it comes, right? This point is b, right? You just say as this point is b, that is minus 1 comma 4, and this point is 2 comma 3. Okay, so like that we can represent in a polar coordinates, right? We are presenting in a polar coordinates, and this form of line, if the plane having, so generally the plane having, so complex numbers, the plane having a complex number assigned to each of its points is called as a complex plane or argand plane, right? So the plane having a complex number assigned to assigned each of its point is called complex plane or argand plane. You just note down this definition. Okay, what is the complex plane or argand plane? The meaning is same here. Okay, so the coordinates we are representing in a plane, so by the sum of points, by the points, right? So that will be called as uh, argand plane or complex planes. Now um, generally when we are writing a equations, okay, x plus I, this is an equations. Okay, when we are finding the value of modulus of this value, right? Modulus of this, right? So modulus of this, we can write modulus of this complex number is, so modulus of complex number is x square plus y square, right? This one we know, and the point is for the point is x comma y, and when we are presenting this one, this is the distance, like a, it is a distance, right? It is a distance, is a distance, is a distance between, is a distance between p x comma y and the original point, right? So here, so modulus of this is the distance between the p and distance between the p and o, right? And this is o, and the point is somewhere here p x comma y, and this is the distance between p and o is a root of a square x square plus y square. That is the modulus of uh, complex number, right? So when we are presenting, so the conjugate numbers lies in a here, when we are representing a number px comma y, so this from the origin point, and the point, the conjugate point will be, so x comma minus y, right? The conjugate point will be x comma minus y. So now we'll take an example to find the conjugate of the number, right? So we'll take an example of, so 3 minus 2i into 2 plus 3i divided by 1 plus 2i, 2 minus I. We need to find conjugate of this number. So before going to solve the conjugate numbers, we need to resolve these equations. So we just need to multiply here. So 3 2s I is what? 6. Here 3 2s I is 6. Okay, 3 2s I is 6 here. 3 2s I is 6. 3 3s I is 9. So 3 3s I is 9 plus 9i, and this point I am taking minus 4i, right? This is minus 4i, minus 4i, and this point to this point is minus 6i square, minus 6i square, and this is 1 into 2, so 2, and 1 into I is minus I, and here 2 into 2 4i, and this is minus 2i square, right? So this the 6 plus, so 9 9i minus 4i is 5i, and this is I square is minus 1, so minus 1 into this will become a plus 6, right? You just because I square value is I square is value is minus 1, minus into minus 1, minus 6 into minus 1 is plus 6, and this one is that, so 2 minus this minus I plus 4i is plus 3i, and this I square value is minus 1, it is minus 2 into minus 1 is plus 2, it will become a plus 2, and now with this will be, so this will be 6 plus 6 is 12, so 12 plus 5i, and here we'll be having 4 plus 3i, right? 4 plus 3i, right? 4 plus 3i. Now what we have to do, so here the denominator term we are having 4 plus 3i, so opposite to of that means opposite of that means conjugate of that is 4 minus 3i. We have to take 4 minus 3i on both sides. We need to multiply here denominator term we are having 4 plus 3i, so we need to 4 plus is there, minus we have to take 4 minus 3i, we have to multiply on both sides, and we again we have to multiply this one, right? We need to multiply this one. So what terms will come here? 12 4 is 48 here, and 12 3 is 36, so that is minus 36, right? Minus 36, 36i, and this 5i 20i, and this minus 15i square, and this, so 4 plus 3i and 4 minus 3i, this is in the form of a plus b into a minus b, so that is the formula for a square minus b square, right? It is a square minus b square. I just write here a square 4 square minus b square is 3i square, right? It is a square minus b square. So this one 48, and this minus 36 plus 20 is minus 16i, and this I square is minus 1. Minus 1 into minus 15 is plus 15 here, right? This is 16, and this will be minus, and this will be 9 I square. I square means it is I square is minus 1. Then we are solving here 48 plus 15 is what, 63. So 63 minus 16I we are having here. So here I square is minus 1, minus 9 into minus 1 is plus 9. 16 plus 9 is 25 here, right? So and then it is 63 divided by 25 and minus 16 divided by 25I we are having. So and conjugate of this number is, so conjugate is means what, here we need to take plus, right? When plus minus is there, then plus will come. If plus is there, minus will come, right? That is the conjugate of number. So 63 divided by 25 plus 16 divided by 25I. So this is the conjugate of the number. Okay, now uh, so now we'll take so another example. We need to prove. So example is 8 here. We need to prove that is x plus I y. Okay, I y is given a plus ib, uh, to the denominator term is a minus ib. So we need to prove that, so x square plus y square is equal to 1. In this we need to prove x square plus y square is equal to 1. So here in these equations, so we need to a plus ib is given, and denominator term is a minus ib. I just multiply this here term on both side, a plus ib, a plus ib, and if we multiply this one here, it will come as a square minus b square plus 2ab I will come, right? This is a plus b into a minus b is what, a square plus b square will come, right? So a square minus b square, and here I square is minus 1, or minus 1 will get positive, here positive term will come, right? And if suppose this one we can split this values, we can split. So a square minus b square divided by a square plus b square, and this term I am writing in separate. So that is 2ab 2ab divided by a square plus b square I, right? This term I am writing separate. So now, this is what, this is x plus iy, right? X plus iy. And now so that, so if we are writing x minus iy, what is the value of x minus I? It is a conjugate, here minus will come, right? It is a square minus b square, a square plus b square, and here, so x minus y I am writing, so here minus will come, minus of 2ab divided by a square plus b square I, right? When we are multiplying this one, so when we are we need to prove x square plus y square. X square plus y square we can write as a product of this, right? X plus iy, x plus yy into x minus iy. When we are when we are multiplying these two, we'll be having x square plus y square. So we need to multiply this one, so it will come as, so here a square minus b square, the this term and this terms are same, then it is, it will get square, right? It will get square, a square plus b square, and it is square, and here plus, and this term it will get also it will get also positive here, it will be positive, and here, so 2ab 2ab means it is 4 a square plus b square divided by a square plus b square whole square will come, right? Now if we solve this one, so again, so here both LCM are same, right? Here both term LCM are same, it is a square plus b square of whole square. And now when we are solving this one, so when we are solving this one, a square plus b square, so it will becomes as a square plus a square plus b square of square will be having, right? So when we are solving this one, so this LCM is same here. When we solving square, when we take the square of this and adding of the 4 plus ab, and remaining term will be a square plus b square, and this term will be get cancelled, and will be having finally is equal to 1. Okay, so now this your chapter 4 is completed. Okay, in next class we'll be going to discuss and we'll start the new chapter, that is linear inequalities, right? That is chapter number 5. And thank you for watching the video. Please subscribe the channels, hit the bell icon for the notifications. Please do share with your friends. Thank you.